Muy buenos días con todos. Agradeciéndoles a los participantes del día de hoy por estar aquí en IC Talk 2022 en su segunda edición, en su segundo día de agenda. Para recordarles que el día de hoy tenemos como invitados para charlas al doctor Mohamed Joyafar y al doctor Marco Guevara en el transcurso de la mañana. Por las tardes tendremos los talleres acompañado del doctor David Rivas con el tema configuración de nodos y plataformas para IoT y el doctor Julio Bravo con nuevas escenografías discursivas desde la comunicación y las TICs. Y finalmente con el ingeniero Christopher Coronado, el de la construcción y consumo de un modelo de regresión lineal con ML.NET y Angular. Ya. En pocos minutos nosotros tendremos la intervención del doctor Mohamed Joyafar, por lo que les voy a hacer primero una breve introducción de su hoja de vida y seguido en español y seguido lo haremos en inglés hasta que el doctor se conecte. El doctor Mohamed Joyafar estudió en la Universidad Sapienza de Roma, graduado con honores. Actualmente trabaja en la Universidad de Zurich como profesor asociado. Mohamed Joyafar es señor y miembro de la IEEE. Tenemos también que él actualmente es a Senior Lecture Associate Professor en seguridad en redes y en IES y miembro del IES. También nosotros tenemos que el doctor Mohamed Joyafar trabaja como Intel Innovator and Professional ACM Member. Bueno, les voy a leer mejor todo en inglés porque hay algunas cuestiones que no, casi todas las donde que trabaja y todo en inglés, entonces mezclarles ahí como que ya no va. Tenemos Mohamed Joyafar is a senior member IEEE, received a PhD degree with honors in ICT from the Sapienza University of Rome, Italy in 2016. He is currently a senior lecturer associate professor in networking security and an IES member, an Intel Innovator, a professional ACM member, and an ACM distinguished speaker, and Marie Curie alumni. Working in the 5G and 6G Innovation Center, Institute for Communication System in University of Surrey, UK. Before joining communication system, 5G, GIG, and CG, he was a senior researcher and Marie Curie Fellow with the Esprit Security and Privacy Research Group, University of Padua, Italy. He is a PI of AutoTrust and of 750 euro 5G secure autonomous vehicular communication project supported by the European Space Agency in 2021. Also, and was a principal investigator PI of a PrinceNode project, in Horizon Marie Curie project in the areas of fog and cloud security, collaborating at the University of Padua, Italy. He also was a PI on an Italian SDN security and a privacy supported by the University of Padua in 2018. He also was contributed to some Italian projects in telecommunication like Gaucho, a green adaptive for computing and networking architecture. S2C secure software defined cloud and some cloud secure and adaptive management of multi-clouds. He main research interest in the area green networking and network security and privacy. He published more than 140 papers in the topmost international peer-reviewed journal and conference in this area. IEEE TCC, IEEE TAI, IEEE TNSM, IEEE HOS, etc. He is having the H index 35 and more than 4,800 citations. He is associate editor in IEEE Transaction on Networking and Service Management, IEEE Transaction on Consumer Electronic, IEEE System Journal, and Computer Network. More details you can find in his webpage. I will put in the chat. Yeah. Vamos a ver si el doctor está ya conectado. Sí. Por favor, si esperamos unos minutos porque está con unas reuniones importantes, pero ya me supo decir que nos acompaña en breves minutos. Muchas gracias y estamos a la espera.
El proyecto de investigación InfoProject y la carrera de Ingeniería en Tecnologías de la Información de la Universidad Nacional de Chimborazo, Ecuador, te invitan a participar en Second International Congress Innovation Research and Technology in Information and Communication Technology, ICTAR 2022. Evento virtual a realizarse del 21 al 25 de febrero del 2022. Para más información, visita nuestra web ictor2022.unach.edu.es.
La carrera de Tecnologías de la Información surgió por la necesidad de contar con profesionales que ayuden al desarrollo sustentable de la sociedad en el campo de tecnologías de la información.
Estudia los principios, metodologías y estándares de calidad involucradas en el proceso de análisis, diseño e implementación de las tecnologías de información en un organismo institucional, en las áreas como son redes, programación, infraestructura, seguridad, base de datos y servicios web, lo que contribuyen al desarrollo productivo, local y nacional, así también como el acceso universal a la información y comunicación.
El objetivo de la carrera de Tecnologías de la Información es formar profesionales éticos, competentes y emprendedores con conocimientos prácticos y teóricos para diseñar, implementar y evaluar soluciones de tecnologías de la información. Otro de los objetivos de la carrera es permitir el acceso al conocimiento científico que es necesario para desarrollar las competencias profesionales que contribuyan al desempeño laboral en las áreas de redes, programación, seguridad de la información, infraestructura, desarrollo de software y aplicaciones web.
La Universidad Nacional de Chimborazo nos brinda varios servicios como son el uso de laboratorios y equipos de última tecnología, acceso a la plataforma, aula virtual y biblioteca. Tenemos también áreas verdes y espacios de recreación. Un servicio adicional, contamos con un incentivo a los estudiantes que obtienen el primero y segundo lugar al culminar cada semestre con las mayores notas A eso lo conocemos como son las becas académicas.
Ven y sé parte de la maestría académica con trayectoria de investigación, Auditoría de Tecnologías de la Información. Conviértete en un investigador competitivo con conocimientos sólidos en técnicas, herramientas y metodologías. Mejora tus habilidades científico-tecnológicas y contribuye con la productividad futurista de nuestro país. Dirigida a profesionales con títulos de tercer nivel en áreas como sistemas, informática, tecnologías de la información y otros campos del conocimiento relacionados con las TICs. Para más información, visita nuestros contactos oficiales.
Ahora tenemos al doctor Joyafar en línea. Thank you, Mohammed. I have given to the participants and share introduce about you. Thank you so much, Mohammed, to be here and be part of the IEC Talk 2022 in the second edition. And now we have your participation. Thank you so much to be here again, and continue, please.
So thank you very much. And do you hear me, Paula?
Sí, I can hear you.
Okay, brilliant. So I just need to share my screen, and I hope that you can see my slide. Is that correct?
It's okay. We can see your slide.
So brilliant. So thank you very much for all of you that, sorry that was a confusion here. There was a clash with some other meetings here. So, I'm Mohammed. So I'm so glad to present the green computing and networking in cloud and fog computing. Mainly, we'd like to talk more about the different problem and formulation and the solutions we got since the last 7 years. So the agenda, our discussion will be devoted onto the Grid Cloud Data Center. After that, we'll go ahead and discuss more about some networking activities I have done during my research. And also at the end, we'll go some future direction that think that right now we are dealing with our team here in another partners in the country, in UK and also in Europe. And at the end, it will be references of some of our achievements. So if we move starting by the data center, so the most important things come to our mind based on these explanations here. I just want to. So you can see that the data centers are comprising of different servers and different racks, and a lot of the hardware and software devices are connected to there. This is just from the physical point of view of seeing the informations. But the other information that comes from the data center is that data center is a main part of the processing information in the world. So any information in a network that you will generate from the down part, from your IoT devices, from your mobile devices, from the different parts, this information should be passed to the internet, from the internet to the different layers, reach to the data centers spanning all over the world, and do the analysis of that kind of information and send back the process information back to the users. So the important point comes to our mind is that what do we need from our data centers? Due to the talk that have been done by Kava team in the Green Cloud Next conference in 2017, the main task of a data center is mainly talking about accessing a high performance computing on the system and also provide a reliability and security of the information of the users. So providing this problem, so we need to design a data center and also the proper algorithms that these algorithms could be applied on data centers in order to provide a high efficiency of the system. So you can see data centers are consuming a lot of electricity and they generate a lot of heating systems. So providing a cooling structure is one of the other problems that we need to take into account. Also, how we could design a proper voltage distribution inside the data center is another problem. So recently, I just want to starting by chronological way of the research that I have done is starting with a data center. And the solution have done in this activity so far was mainly they would like to provide some high performance of the information transferring the systems, provide a dynamic allocations in order to allocate the information to the different available servers in the system to make it the dynamic analysis. And also how we could preserve a high range of data center. For example, from 100 server, we reach to 1,000 server, how we could deal it in a specific country, for example. This is the providing a scalability is another problem are dealing in data centers. This problem could be much more sophisticated since last 10 years that the cloud platforms are engaged. So as all of you are aware of the cloud computing, so cloud computing provide more on-demand computing resources over the internet. So it will allow more users from all over the world could get access to the different applications generating Somber. For example, one application have been generated based on some of the programmers in Ecuador. So I, sitting in UK, can get access to that application and generate traffic. So you mean that now the amount of the information have been rise enormously. Also, the number of the applications are rise enormously. So in order to analyze these informations coming from different parts of the world, we need a cloud of data centers that they're located different parts of the world that they help us to analyze the information. So in this case, this challenge of data centers would be much more crucial to providing energy efficiently, cost efficiently, and minimize the delay. The information, for example, you are requesting from the application that it's come from the Asia. You're requesting that information less than 10 seconds, less than 5 seconds based on the request of your system. So, I mean, providing a minimization of the informations or the application's demand is another issue. Also, satisfying the quality of the services and robustness of the request is another issue. This is the whole part of the following slides. We will work on the different problems that have been resolved theoretically and practically in different locations. So motivation by this kind of generations, with this kind of explanation, I say to you. So there are different famous work have done in literature that have been published in very famous places, like a Google team that have done some task, Microsoft team some tasks. So this is a project have done by a Microsoft team in Stanford University in 2014 to analyze the functionality of the network and also provide a multiple data center efficiency of the demands. By analyzing this information, I have realized that these solutions, these algorithms still has a lot of limitations. These algorithms, sometimes they discard same time, cost, and performance per request on cloud data centers. So motivated by this idea, me, my colleague in Italy, in telecom company, in University of Melbourne, and the Deakin University, we come up with some practical and analytical solutions that in order to analyze this kind of problems, how we could come up an optimized solution to jointly could tackle energy, cost, performance of the per demands per user in cloud data center. So these are some I just want to go ahead into some of the most important solutions in transaction papers and also in ICCs. Also, the good point is that all of this works that we have a law from the partners. We get access. You can get access to the code there in this link that you can see the materials there. Let's start by first work that we done it in 2013. We just want to consider that there are in this architecture, you can see that the information are coming from internet. So there's a gateway or routers that they could route these informations and send the information to the inside of the one cloud data center. In order to transfer these informations, which is coming from different applications inside the system, so there should be a buffer here that they could provide the admitted workload, that this kind of workload coming to the system based on the capability of the data center. And also the data center will support, we could consider it into 3 points. The first point, or the first part of the center, mainly task is to provide a dynamic virtual machine learning and also task scheduling. So when the information, when the traffic, we call it traffic, when the traffic coming to the system, we need to dispatch it on the available physical computing and communication resource in the system. So we can call them as servers. So there are different servers in order to reserve that kind of traffic. Above of the servers, we have a virtualization layer. We call it computing and communication virtualization layer. So it could be based on the Docker, based on the different applications, or also based on the VMware, for example, just more common situation. So we have different virtual machines could run ahead of the servers, that these kind of virtual machines could receive a portion of the whole traffic coming into the system. And there is another component, they call it virtual switch, that it tasked to send back the information to the available virtual machine and received the process information back to the system, and again integrate them and send back out this information, send it to the users. This network, this called it network data center, because it can process the computations and communications inside data centers. By considering this point, we have formulated this problem in order to minimize the total energy consumption of computation over the virtual machines and communications between the virtual machines inside the data centers. So in order to ease the problem, to make it easy for all of you to understand about the main concept of this problem, we just make it very descriptive, but this is full of mathematics. If you'd like to go ahead and study more in details of this kind of solutions, you can get access to the paper. So we have some limitations in the system. So each server has some limitations, has some capabilities. So one of the capabilities is processing capacity of the server. Some servers could do a specific processing. For example, if you consider a server as, for example, your PC, your processing unit, or let's call it your frequency of your CPU is limited. For example, 2.0 gigahertz. So not more than that it works. So this is the limitation of per devices or per physical system we have it. And again, I want to say that we have a virtual machine ahead of physical systems. So we will have that kind of limitation as well. Also, we have some other limitation. They call it delay constraint. The time of sending information and sitting on the communications and receiving informations. This is, they called it 2 time of this end-to-end communication, plus the time it takes to process the portion of information inside the virtual machines. All of these time constraints should be less than the total time requested for each application. So we have resolved this problem, and we have found solutions mathematically, analytically, and These are some solutions here we have tested in different heterogeneous network. And we said that we have considered this one on different heterogeneous models, and you will see that our optimization solution or algorithm we have proposed, it should come up same time considering computation and communication inside the model. Yeah, in order to find a solution, I just want to give you ideas, some of you that they would like to go about how the mathematics have been calculated. We use a Krush-Cohn-Tucker or KKT condition in order to find a solution and provide the Lagrangian method on these techniques. The important point is that this solution is not only offline solution, it's also online solution. It means that each demand comes to the system within that time slot that information could be analyzed. On the other project that I've been participated during some years ago, is mainly providing a security and adaptivity of the management of the multi-cloud system. Generally, in that kind of project, our aim was to optimize, provide a new solution, optimization solution that it could support service level agreement, the agreement between the users, and also support the cloud server performance in the system. So these are a collaboration between the time that I was in the University of Rome and also with Modena, Deakin in Australia. And these are some of the outcomes that have been available there. I just want to pick one of them and go ahead. So we have considered different servers located in different places. So we have designed a virtual layers on these based on virtualization mechanism ahead of the physical layer, ahead of the server capabilities. And in the down part, we have, we call it the front end side. We have received the information from different clients. And this gathers this information through the gateway on a data chunk size, means that we have gathered all the traffic and then we split it, chunk it, and send it each portion of information to the available servers. And our task is to minimize the total energy consumption of the model. As you can see, our aim is to minimize the total energy consumption of the model and maximize the profit, means that I would like to minimize the total cost plus increase the speed of the processing informations. So we have used a video stream data chunk coming from the Microsoft, and we have analyzed this information on different server level agreements that they care about the computation and communications. This is another optimization problem. As you can see, total energy consumption in the model with some system constraints. And we found a solution based on a processing time that we can send that portion of or that chunk of information to each server, and based on the optimizing the bandwidth per server in the model. So we have analyzed it locally on the synthetic workload and real workloads, and we have compared our solution. It is called MM-Green with some existing techniques like Lyapunov techniques, hybrid techniques, or NetDC, which is the original techniques that we have published, proposed before. The good point of this technique is that we have tested this problem on a huge number of virtual machines in the network. So, and also it confirms that this model is capable to support cloud data centers in the system. The next category of my discussion will be devoted to talk more on the green networking. So the green networking activities which I participated was I just draw a back to three category of the project I have participated in Europe and also in Italy. So the first one is the Horizon 2020 Superfluidity project, which is a mainly on 5G project. Gaucho is the Italian project. Also, Paolo was contributed with me in that project as well. And we have also participated on some Padova University and Canada. This is a project between a telecommunication in Italy and telecommunication. The other project, telecommunication in Ontario in Canada. I just provided some of the links of the project. You can get access more material on them. Let's go and summarize some of the activities related to green networking for that project. Generally, aim of this project is to design a super fluid model on the 5G system. So it helps us in order to, this model will be located in different layers of the 5G model, whether on the core, on the aggregation, or on the edge layers of the model. The good point of this project is that this project was a huge project, around 7.5 million euro project I was contributed. And I was in the partner of the CNIT, which is a coordinator of a team, and 18 European partners like Intel, Nokia, Bell Labs, Alcatel, Red Hat, Citrix in Greece, and British Telecom was participated there. And our task in that project was to design a network, green network model on a cloud, and also by the help of the software-defined networking infrastructure to the model. Also, this outcome of this project is not only a research publications, but also a software demo. You can get access to the demo to this website as well. So I just categorized this project into some parts in order to make it very more details of what have we done in the superfluidity. So the first one is about the software-defined cloud data center. So in order to go ahead, so we can see that the model is as a software-defined the cloud data centers could be like this here. So we have different physical systems or the servers that are located in the down part of the pod. They are connecting with different switches here. For example, we use FAT3 switches. That this is an existing technique of the switch are communicating to each other. So we can call them, this is a middle layer switch. And we will have some, let's call it edge switch, that these edge switches are located on a data center network core. Each physical system or each physical server, they have some virtual machines and some virtual routers. Virtual machines has to do the processing. Virtual routers is to route the processed information out to the other physical switch or the switch to the other, through to the middle switch or the core switch to the other physical systems in the other pod. The model form a software-defined cloud. So as you may know, the software-defined model has two parts: control layer and data link layer. These are located as a data link layer. The data is transferring, and we will have a core management that its task is to give an algorithm, process algorithm to run how these physical systems are communicating to each other. By considering this algorithm could be located at the network manager, through to the network manager send information to the allocation manager, and through the allocation manager could manage the physical system in the model. The whole idea was in this model is to minimize computational cost of the virtual elements, including virtual machines and virtual routers, because each of them consume energy. So we would like to minimize the total energy cost of the computation costs of this model, and considering migration. If you would like to go ahead, this for migration is that, for example, this physical system has some problems, some failures, some problems. So we need to migrate some of the information located on the virtual machines in the other physical systems or other pods in other physical, other servers in other locations. So in order to provide this system, so we come up with some energy minimizations and migration on a cloud data center. Here is the optimization model, and I just provide mathematics. I skip the mathematics explanations, just make it very easy in order to understand it. We have some server utilization constraints, communication constraint. We have some communications constraint in the model. We have memory constraint and also migration constraint. Each virtual element cannot do very far because it depends on the capability of the processing informations. And we found a solution in different cases. Also, we have validated the result into a different time slot. So we have found a solution exactly in that time slot. The data set, we have tested this model on a United States government data center in the California in the Energy Star model, and we have considered this one in different virtual routers. So we have considered 20% virtual routers and 30% virtual routers and validated the solutions in the model. Also, the data that are coming from a private cloud, that is belongs to the eHealth applications, and it completely belongs to the Cisco. By the help of the Cisco, we had this kind of analysis. And we have compared solutions. So we have proposed 3 different solutions: adaptive solutions, adaptive with the smoothest solutions, and Newton-based solutions. And we have compared them in different cases, and we can see that our average total energy cost is compared to the other existing techniques are much lower than them. So for example, these 3 in the right side belongs to our techniques. And the other activities that belongs to the other green networking, we move to do on purely on 5G cases. In order to make it very easy for you, is that in the 5G model, there are different users. These users could generate traffic and send information to the base stations, or we can call it to a model that could receive the information from the users. In order to transfer the information in the 5G system, they should use multi-user MIMO radio link model to send information in the system. There's a technique that have been done specifically in the communication part. This information should be processed locally or send it to the 5G core for processing. In order to do this, we need to define different RRH, broadband unit, and mobile edge computing applications or services in the system. So we have different block of the information should be located on each kind of uh, microcells. For this microcell, that could run with different radio channels, the broadband of the baseband of the signals, and also the information or the pool of the requests to process the informations. And what is the objective? The objective is what is the optimality in this model? We would like to find a proper RRH, BBU, and MEC units. We call them RFB, reusable functional blocks, inside a mobile cells and microcells, so instead of microcells on the 5G network to support some KPIs. In this model, we consider energy consumption of this microcell. We would like to minimize it, and we would like to maximize the throughput, means to send back the information much fast as it can into the system. By considering this point, we have optimized the model. We aim to maximize the throughput and minimize the number of the nodes. I just again want to say to you that this is one of the 5G nodes that it's still is valid, is working here, and I'm sure in Europe and also in America is located this as one here. So we would like to decrease the number of 5G nodes because 5G nodes cost a lot. So we need to decrease the energy by decreasing the 5G nodes. So there are some limitations we have in the model, and we have optimized the model based on the binary replacement techniques. The other techniques that is mainly on the SDN. So we also move to the network part and discuss how we can find the energy consumption, green networking or sustainability in the model for the software-defined networking models. So in this model, I just want to give you an idea what is the models coming from. So there are different clients. They can generate different traffic informations. Different informations could go to the network. The network that we have considered is a software-defined networking. Software-defined networking is a 2 layers networking that it's coming from the down part. It's a data layer. So data layer, there are switches that each switch are capable of receiving this traffic information and send information by routing to each other and send it to the upper layer. The upper layer, they called it a control panel or control layer or controllers. It includes different functions, how to configure monitoring the traffic coming from the switches. And above the controller, we have an application layer. The application layer is the running applications to process the information. They called it software-defined networking. We aim to design a service function chaining. Service function chaining means that each traffic, the demand that coming from the clients, they should go on a specific, should visit on a specific switch. So some switch has some services that for that client should do that process. For example, the client wants to send information from here to from Ecuador to, for example, to Chile, but there are different switch between Ecuador to Chile's. But the important is that this switch, some of them, they can do some process. For example, some switch can do net activities, net stat activities. Some switch can do firewall activities. Some of them, they can do some printing services. So there are different services each switch could support it because the host connected to the switch could support that kind of information. That client say that, for example, I send information to Quito, and from Quito I will send it to the capital of Chile, from one of the other neighbors, other country neighbors, and it should go, for example, to California, and then it should reach to the Chile. So it means that these links should pass. So there are different services should run in exactly that link. They called it SFC, service function chaining. So we should have a chain of informations. This is the thing that right now Cisco is dealing with. So the question is that how we could design a server to this kind of host that it could consume less energy while providing the SFC in the model. The situation is this, is that for the software architectures, so we have a resource allocations, means that when the new arrival flow, means the traffic information that should pass for different switches, they should do some allocations and they should do some configurations on a switch. But if there is a failure Let's assume that we have a failure in one of the switch has been failed. So how we could redesign, or let's call it reallocate the information in the network. Or we have, for example, network congestion. So we need to have another module, we call it resource reallocator, that this resource reallocator should do the reallocation while the congestion will be happening, or maybe the inter-arrival time will be happening. So we have a reconfigurations on the switch. So how we could do reconfigurations, support SFC, and minimize the energy consumption in the whole model. So we have find the optimized solutions and have tested in the real case in Abilone and ATMPLS and GoodNet. There are three different topologies we have considered and analyzed this information in the network. And we have come up with the short-term and long-term solutions. Short-term means that we skip some of the cases and we relax the model. And for long-term, we consider all these criteria together, and we see that our energy consumption is much less than other techniques in the literature. The same for the path loss and configuration overhead. This case could be a bit more extreme, that we would like to design an application inside a SDN model that they consider failure and fault together. So this is the other problem that we have considered in 3 years ago, around 2.5 years ago. So this model is the other problem that the Cisco was dealing. So this project is done by the help of the Cisco team. And we consider different virtual network functions. These functions are could be located on a fog based on their demands. As you may know, fog system is a system that are nearer to the clients, could do some processing locally rather than upper layers. So this client wants to do some specific, let's call it critical infrastructure applications. For example, remote surgery. They would like to do some remote surgery, for example. So the process should do locally before that send it to the cloud, because if the information should be sent to the cloud and return and the patient is dead. So it's better to go it with a very fast analysis. So the importance is that if these fog nodes are connected with a fog system or fog servers, and they have connected with a host or the servers there that they could process the information. We consider this the same problem as I explained before, service function chaining, in the case that we have a failure and fault in the model. So we come up with the FRFP, the failure recovery and fault prevention model, and our aim was to minimize the energy consumption and decrease the network side effects. Network side effect is generally saying about changing of the topology, because when the one node is failed, the topology completely change. When the change of the topology from the current state goes to the next state, the network has some side effect, has some missing information, some congestion information, and some, let's call it collapse informations. So how can we minimize this collapse information? We called it side effect in the system, while minimize the energy and not consider failure. This is the case that we consider in the model, and we have find the proper solutions and tested in real cases. Let's move to the project that we have done Italy with Paolo and there. So as you may know, this project is a collaboration between the 4 Italian universities, including University of Rome. And the main work was on the fog computing and fog data center. And I just want to go ahead for the NetFC, one of the solutions that we have designed there. With NetFC or NetFog Center is cloud fog and vehicle architectures by considering the problem. The problem is this. Different vehicles are moving in the road, and they get access to the applications, their own application. For example, I'm just using my specific ECU applications, my specific car applications. So I will generate some information. This information should go to the nearest roadside unit. Roadside unit is processing information, could be located in there and could be analyzed locally. And the other thing is that this roadside unit should be located on a fog node. This fog node is a switch that they could have some processing information locally. And send the processing information to the nearest roadside unit while this user is moving to the next cluster and have this coverage informations. We have considered in this model the total energy consumption of one fog node, as you can see, is in the pentagons here. So this fog node is this. So we have aggregated input coming from the vehicles. We have admitted traffic is the input buffer in the models. We have a small, they call it a small size center, a small size data center. And we have analyzed them on the different physical servers, and we would like to minimize the total energy consumption of the model and then process the load information out of this network. The difference between this approach and the old approach is that this approach not only consider the energy consumption, but also increase they call it the performance, and also send a good put in the network. It means that you would like to minimize the energy consumption here, plus maximize sending information to the users in a local data center, in the local cluster, that before leaving the cluster, I will send information, process information, receive the processed informations. So here is exactly the same. We have an optimizations model. We would like to maximize the throughput of the fog network. And we also would like to minimize the total energy consumption on each fog node. We have some limitations. The problem was NP-hard problem. We just go to find some adaptive mechanism. They called it the admitted models for the workload, and find a solution. I skipped the way how we can resolve it in order to save time. If you're interested, we can go and study this paper. I just want to say that this work also was around 2 years, was the most popular paper in the transaction of cloud computing. Here we have some analysis there in order to do with different number of the fog nodes, and you can see how can the model could be sustained, and the average total energy consumption won't increase too much compared to the increasing the models. This is the other criteria we consider. Since we have an input buffer and output buffer per fog node, we have found the average fraction of accepted requests by relaxing or increasing the length of the fog nodes, and we can analyze it. If we increase the fog node queues, what will happen for the admitted workloads, and the delay have been influencing the system. So this will help us to understand about how the admitted requests have been tackled. If you move to some other recent works that we have done, so if you remember it, that paper, that work is mainly just on one fog node. We skipped that, how we could, let's call it, migrate some information to the other fog nodes in that work. But we had analyzed this one also in other fog nodes. So we have a primary fog node, we had a secondary or other fog nodes. How we could receive information from the end users, process locally, or send it to the neighbors, or send it to the cloud. How we can do it? So we consider that based on the each data coming from different users, some portion of them should be located on the primary fog node, and some of them should go for the secondary fog node and the cloud. And we have separated these informations, and we call them as offloading informations from the one fog node to the other fog node, or from one fog node to the upper layer as a cloud. And we find optimization problems, solutions based on the delay, because delay is really important in that model. I just want to explain some of the most recent techniques that we have worked on these. They are mainly about the virtual machine placement. So we consider different IoT applications generating different traffic. So we would like to see that if these applications are prioritized applications. So we have some applications, they should be higher priority compared to the others. How we could analyze this information, how we could allocate this information to the existing virtual machines and existing servers in the network. So we come up with two optimal solutions. So we consider the demands into critical and the normal demands, and we have find the proper VM joint optimization solutions to find the activities. And we have go deep on analysis on these as well in these activities. For example, we can see the optimization goal for that model is we would like to minimize the power consumption, resource wastage, and network consumption in that model, and we find the proper solution there. For the other problem, we also consider task scheduling between a fog and cloud. The importance is that the approach so far we have discussed, we just explained about the applications only work on cloud or only work on fog. We didn't say that some applications, some portion of applications could do on fog, some of them could be on a cloud. So they are not the Unity applications. If we have some cases like these, so we need to do a task scheduling based on the fog and cloud together. So by considering this point, we have considered a minimization of the communication and violation cost. Because if you separate a whole task into 2 subtasks and send it up, so maybe you will have some violations. So we would like to also decrease these violations of the demands. And we will come up with 2 solutions. And it has been published recently in ACM transaction paper. If you were to go into details about how it works, you can get access to this paper. The problem also, we have gone even deeper on the problems. So we said that let's assume that we would like to find a heuristic or meta-heuristic algorithms and a scheduling algorithms that scheduling algorithms that could be located on the fog broker, receive the information status from the IoT devices through the gateway, and send based on the status of each fog node and the cloud nodes, wants to decide which type of the application will be transferred from one will be located on the fog nodes or on the cloud nodes. We come up with classifications between a deadline and interaction ratio, that some portion of the task could be located on a fog, some portion are located on a fog and cloud, or some portion on a cloud. So we have separated the demands into 3 types based on that criteria that we have defined in the model. So we call the criteria as a percentage deadline satisfied task. And based on that kind of, let's call it metric that we have defined, we have separated the task coming from the IoT devices to the fog or cloud. And with this problem, we have tried to minimize the computational time, energy time, and deadline satisfied tasks. So far, we have explained about all existing work that we have done in literature and also recently done in different theoretical and practical solutions. In the following slides, in the remaining time, I would like to draw some future activities, the things that we are still working, and also we are keen to work with some other of all over the world with audiences. So we had a paper with Paul at that time that it's mainly work. We have designed a fog of everything. So we were pioneer of the fog of everything model. So we said that fog could work on different models, different architectures, different applications. These are some slides that explain this to confirm what we said some years ago. The first slide explained about the fog model can work on providing the green on internet energies, could be applied on a smart grid. So you can see a smart grid could receive, let's call it generate electricity from some systems, or consume electricity in some places. You can see here, like electrical vehicles, intelligence buildings, smart home, whatever. We need a fog data center that to manage these energies are coming from different entities, different type of the communications. Maybe the energy is coming from the wind farm, the energies could be transferred on the distribution power networks. So we need a fog data center as a central manager in order to understand the traffic, in order to provide the proper scheduling algorithms or allocation algorithms, and speed up this analysis and provide more green networking in the system. The other example is on the applying of the fog model on a smart city. As you may know, fog is a model that is nearer to the users. So when the users, specifically in smart cities, different smart cities type, we can Industry 4, smart energy, smart home, IoT devices, and smart mobilities. All of them are some portion of a smart cities in a big city. So we need a fog that these fog models, it could have some storage, some processing information, and some internal applications that these fog models could do the processing of the traffic, or as some other fog models to do the processing. We call them a remote aggregation center to do the processing informations. Again, this model could be specified in Industry 4 and 5. So one of the extension of this project right now is running with University of the with the Ecuador University. Specifically, we are aiming to help fog model in order to speed up the processing on the industrial IoTs or Industry 4 and 5 on the smart and intelligent factories. So the fog model could help the IoT physical resources to easily get access to the remote terminals and do the processing, do the activities in industry much faster and much easier with a less, let's call it, burden for the users or for the industry holders. The other important point that still we are working now with our teams in here is how we could use fog model for speed up the real critical applications, like remote surgery, video streaming, robotic control, and these kind of some examples of the real critical applications. How we could do streaming. Streaming is another problem, means that I don't want to do it advanced here. I just want to receive a stream of information. So the fog could do it locally, the first stream, the second stream, the third stream. So we have a stream of information are coming. So we need, so it's a combination of the demands on Wi-Fi models or on the 3G, 4G, or 5G base stations. So we need a fog node here. It has some servers or network processors locally to process the information and ask cloud to help these models. So these are some energy efficiency models that we are dealing in this direction. To wrap up, so in these explanations, in this slide, I do my best in order to explain what did I do with my team in UK, in Canada, in Italy, in other countries, and a lot of collaboration we had it. So I just try to squeeze it. I'm sure that it's very fast presentations. I hope that you can watch this later. And if you have any questions, I'm available to go ahead for this. So for this kind of conclusion, I just want to say that we understand the model, different network, real network model, and network green networking problems for theoretical and practical situations. And you will see that we have some several optimal and heuristic solutions, problems, and we did some mathematical activities to do the analytical in the robustness of the systems. And also we have tested on cloud and fog environment. The other important thing that we also mentioned in these slides is we did a validation of the presented solutions on different data sets and different KPIs. Also, some of the research that they are more peer research or they have the obligation to share the codes. The codes are available in this link of my GitHub. And these are some other activities we have done in the green networkings. If you like, you can get access to them and try to study them. The good point is that we also ask the famous researchers, famous well-known academic researchers like Professor Rajkumar Bhuya in Melbourne in the cloud team, that we have a free communication with them on different projects we have done together. Thank you very much for all of your attention, and do not forget to pursue your dreams. Thank you, Paula.
Thank you so much, Mohammed, for your nice presentation, and thank you also for your phrase. Very nice and very good for the students to continue her dreams. We know about that. And thank you, Mohammed. I don't know, someone is having a question, if someone want to hand up the hand to for some intervention or some questions. Okay, based on your presentation, Mohammed, I have one question about in the part that you present about the task scheduling in Fog2Cloud. We know that is the real, no? Is the real work because now we have the cloud computing is working and we have that is now that we have now, no? We know the fog computing, we are doing some research, we know that maybe in the future will be available and we work on that, no? But a very good and effective manner. And something in your research in that part, in task scheduling in Fog2Cloud. How about you say that you have some storage for the fog, you say that you have some storage for cloud, and how about time of this? Because you need to apply algorithms to see if need to go to the fog or need to go to the traffic need to go to the fog or need to go to the cloud, no? What
Yes.
about the time? How this manage this? I know that is very good. Is very good scheduling. If it works very well, no? If it works very well, will be exceptional. But how about the time, and how about maybe if collapsions? something about that, if we lose information, how about those kind of things?
Thank you very much, Paula, for raising this question. So in order to go ahead for responding these questions, I just want to say that, so let's assume that we have a traffic coming from the different users, okay? This traffic that have been gathered on fog models or on the edge models, in order to go ahead, we need a distributed a decision to decide that whether I can run this traffic on a fog or I should send it to the cloud. So the network now is equipped, the network system is equipped with this thing that it allows to analyze the time it taken for the demand. For example, one application on your mobile, for example, WhatsApp. So you're going to transferring some information to the WhatsApp from your mobiles to some of your friends in other country. So the information should transfer through to the switch hub by hub, reach to the from the autonomous. They should send it to the autonomous systems outside of the country, and based on the down part, it's sent to the infrastructure and send it to the destination. This information should be based on the demand of the WhatsApp request that should send, because it's traffic coming from the request of the applications. It's based on application demand. Some applications say that I need 5 seconds in order to do this kind of processing. So I will see I have 5 seconds for this traffic. So I can do it to the cloud because I can do it very fast. I can do it in a larger manner, or maybe I can do it in a edge or fog model. Generally, due to the analysis that the Cisco and also some other companies like Microsoft are doing on the cloud systems, and also on the elasticity models, and also in different situations, based on their experiences, based on the analysis they have done, local analysis and also the real analysis they have done, if the process should be done without a 5 second, sorry, it should be done less than 10 seconds, and it could have time to be done more than 5 seconds, it could be transferred on a cloud. If it's below 5 seconds, it's better to run it in locally on a fog models, if the system supported fog model.
Yeah, then we will have many, I think, constraints, because if you say depend of the traffic, maybe if it's having collapsion or having a lot of traffic, if it's in the queue, some traffic, then won't be good if it's going to the fog, because it will take a long time. It's better to send to the cloud, and some small traffic, small task, maybe is fast and will respond fast to the fog, and otherwise will go to the cloud, depend of the time that will take for respond to that request. Okay,
yes,
this is much more clear.
It's correct. It's correct. I should add one more thing, is that how to calculate this 5 seconds in order to make it a bit more clear. For on each switch, there is a virtual circuit on a switch that it could anticipate, or it could estimate that this traffic, if it goes from this hub, goes to the next hub until reach to, for example, 10 hubs from Ecuador, it reached to, for example, Los Angeles user. So it should pass, for example, 10 hubs. So each hubs, it takes, for example, I don't know, 10 milliseconds, okay? And the time of the, let's call it sending and analysis, the information also, it could calculate it. This is anticipation. Again, I want to say this to you. This is anticipation that the first hub should do it. This is for communication cost. This is not for computation cost. And if it reached to the server in the Los Angeles, how long does it take? It's another anticipation that the end user, let's call it switch, should do it. So they will submit all these calculations, and they said that more or less it should be less than 5 seconds when I send the information and when I receive the informations. This is exactly, you're right. It's completely a lot of factors behind it. It's not just one fact, just one value. So this value is completely anticipated, and with some error rates. These are some error rates for calculations. So this is exactly based on the how many hops it goes, which shortest path is moving, and what a lot of limitations that are working with. So now Cisco is also dealing with in order to decrease this time. if I can decrease this time, it's the best for the application providers, because more applications will like to go in fog models rather than cloud models. So this is a competition of money.
Yeah, yeah, that is right. It's competition of money. And you are right, because depend of also the time. Is no, okay, if you have very good algorithm, but this algorithm is taking a lot of time, it's not representing for money also, what you say. And is a lot of constraint that we need to see, but when we implement or we do experiment in the real, no? Because we now in the simulation, we put how as we know and the general information and general parameters that we know, but in the real time is many factors that are inside that, and we need to first do experimental to know how to work in the right way. Thank you so much. If someone else having some question, thank you so much for for your good intervention. We know that many students are interested in work on fog computing. I know that this is a very big issue, but we are the more clear about that, no? About that platform. Thank you so much, and thank you to be here, and thank you to be part of this IC Talk 2022. And we hope that we have a new meeting that we can have invite you. We can collaborate. Okay, we are collaborating now, but we can collaborate with the students. That is the most important, no? I know that you like so much of the students, you like to teach. I hope that we have the opportunity and the chance that we will be hearing Unach with us. And thank you again so much. And I hope to have you in next time.
Thank you very much, all of you, for your time.
Thank you.
Bye.
And have a nice day. Gracias con todos, y por favor les esperamos en la próxima charla, que será a las 10:30. Muchas gracias por su atención y nos vemos en la próxima charla.
El proyecto de investigación Info Project y la carrera de Ingeniería en Tecnologías de la Información de la Universidad Nacional de Chimborazo, Ecuador, te invitan a participar en Second International Congress Innovation Research and Technology in Information and Communication Technology, ICTAL 2022. Evento virtual a realizarse del 21 al 25 de febrero del 2022. Para más información, visita nuestra web ictol2022.unach.edu.es.
La carrera de Tecnologías de la Información surgió por la necesidad de contar con profesionales que ayuden al desarrollo sustentable de la sociedad en el campo de tecnologías de la información.
Estudia los principios, metodologías y estándares de calidad involucradas en el proceso de análisis, diseño e implementación de las tecnologías de información en un organismo institucional, en las áreas como son redes, programación, infraestructura, seguridad, base de datos y servicios web, lo que contribuyan al desarrollo productivo, local y nacional, así también como el acceso universal a la información y comunicación.
El objetivo de la carrera de Tecnologías de la Información es formar profesionales éticos, competentes y emprendedores con conocimientos prácticos y teóricos para diseñar, implementar y evaluar soluciones de tecnologías de la información. Otro de los objetivos de la carrera es permitir el acceso al conocimiento científico que es necesario para desarrollar las competencias profesionales que contribuyan al desempeño laboral en las áreas de redes, programación, seguridad de la información, infraestructura, desarrollo de software y aplicaciones web.
La Universidad Nacional de Chimborazo nos brinda varios servicios como son el uso de laboratorios y equipos de última tecnología, acceso a la plataforma, aula virtual y biblioteca. Tenemos también áreas verdes y espacios de recreación. Un servicio adicional, contamos con un incentivo a los estudiantes que obtienen el primero y segundo lugar al culminar cada semestre con las mayores notas. A eso lo conocemos como son las becas académicas.
La Dirección de Posgrado de la Universidad Nacional de Chimborazo oferta el programa de maestría, Auditoría de Tecnologías de la Información, una maestría académica con trayectoria de investigación dirigida a profesionales con títulos de tercer nivel en áreas como sistemas, informática, tecnologías de la información y otros campos del conocimiento relacionados con las TICs. Ven y sé parte de la maestría académica con trayectoria de investigación, Auditoría de Tecnologías de la Información,